All right, guys, it is time to get to the quadratic formula. We've been hinting at it for a couple of days. What do we do when we need to factor and solve a quadratic problem that we can't factor it, but we still need to be able to solve it? We can't crack that nut with our factoring, so we have to find a new method. And here we go. This is a kind of an example here. I'd need to do a GCF to pull off that -4 in order to use our simple trinomial method. And 9 does not have any common factors with 4. So right at this point, I'm now stuck. I can't GCF, I can't trinomial, but that is still a solvable quadratic. How do I do that? And this is how I do that. I know, isn't this scary? Okay, it might look scary to begin with, but let's unpack this a little bit. First thing I want to point out is you do not need to memorize this. Okay, this will be available anytime I ask you to use it. You just need to be able to use it and plug into it. Don't worry about memorizing it. Okay. Second thing to point out is remember, whenever we're solving a quadratic, when we graph quadratics, remember it's a parabola, and our two solutions on the graph are where it crosses the x-axis. There can be two solutions for any given quadratic. So to find two solutions using the formula, that's where this plus minus comes in. Some of you might have noticed that and going, what the heck? I've never seen a plus minus. What is going on here? Relax. All this means is after you plug in and you start doing the calculation, when you get to the point of actually adding or subtracting this -b with whatever you get after you take that square root on the right-hand side, you just split the formula into two formulas, and you do one version where you add, and you do another version where you subtract, and together that gives you your two solutions to the quadratic. Okay, that's all that's going on there. Don't get too stressed about that. The rest of it, notice, is that x is our solutions. When we look over here on the graph, x equals 1, 2, 3, 4. So if we were to mark it like that, we would say our solutions are at x equals 1 and x equals 4. Well, that's why it's written up this way for the quadratic equation. We're just saying our two solutions for x are going to be whatever we calculate after we plug in. We'll have x equals answer 1, x equals answer 2, when we split it based on that plus minus. Okay? And then notice the letters that are in here are A, B, and C. So we find out where the A, B, and C are in any quadratic equation we're working with, and then we plug them into this formula. All right, let's dive in. In order to pull out that A, B, C, we need to have our quadratic in standard form, okay? Standard form, what that means is it needs to be like this, okay? So number one, notice, it's got to be solved for 0. If an equation isn't solved for 0, this C isn't going to be correct potentially. If there's just, if that C is moved over to the other side as -C, then you don't have the right terms. You need to get it solved for 0, or if that C is broken apart, maybe that C is a 20, and you've got 10 of it on the left side and 10 of it on the right-hand side of the equation, then you don't really know what C is. You're seeing the wrong number. You need to move everything over to the left, so it's all set to 0 on one side and all of your equation on the other. Then your A, B, and C will be correct, so make sure it's solved for 0. And then the second thing we'll notice is that right in front of your x squared, that's your A. Okay, it's not that it's in the front of the equation, it's that it's connected to the x squared. There's your A. B, right there next to the x, coefficient of x. Okay, A is coefficient of x squared, the B is the coefficient of x, and then the C is just the constant by itself. So let's just practice finding those three right now. Okay. A is that guy right there, and we don't see anything. We know what that means. If If you don't see anything, it means it's 1. So our A is 1. Our B is not 6. It's negative 6, okay? Remember, you need the sign to go with it. Always, always, always. And then our C is 7. And it's as simple as that. We would then take that A, B, and C, plug them into the formula, and that would give us the solution to that quadratic equation. And by the way, if you look at this first example, that might be one that we could solve using our trinomial method. You could also use the quadratic formula to solve it, even if it is trinomial method, even if it's GCF factoring method. The great thing about the quadratic formula is it solves every single quadratic however it may look. Whatever other method may work, whatever form it's in, if you write it into its standard form, right here, you can solve it with the quadratic. So you could literally forget all the other methods and just use quadratic every single time, and you'd be able to get all your solutions. And I'm fine with that if you do that. All right, next one, ABC, same idea. In front of the x squared, the coefficient of the x squared is my A. It's my negative 3. And again, I don't see anything there. It doesn't mean I don't have a B. It just means the B is 1. And then again, I need my sign. The C is the negative 9. All right, next. Again, same idea. I don't see anything except the negative. So that means my A is negative 1. Okay, that's the coefficient of that x squared, negative 1. B, I hope you're not thinking it's minus 9. Remember, B is the coefficient with the x. If I don't see an x term, it's not there. We're going to figure out, what does that tell us about B? While we're at it, let's just knock out C. C is that constant, so we know C, it's negative 9. But what about B? We're kind of stuck. Well, it turns out, even in this case, there is a B. There's my negative x squared. There's my minus 9. So what goes there if there is nothing there? And it's this. We had a B term. Wait, why did I write B? Sorry, I should write x. We had a B coefficient there. We had a middle x term, but it turns out the B is 0. 0 times x cancels it off, and that's how we end up with that original version up top, where it's just negative x squared minus 9. So if you're missing the B or the C, because that term just isn't there, it's 0. Okay? We could have the same exact thing if you see an equation like this as well. If you see something like this, the C term that's missing, it's just that there's a plus 0 we didn't write, so the C on that one would just be 0. So going back to the one we were just working on, the B is 0, and so now we have our ABC. All right, now let's take these and walk through this idea of plugging them in. Okay, so we've got an equation, and there's the quadratic, and let's just walk down our steps. First, make sure it's solved for 0. This is exactly the same as factoring, okay? This one is solved for 0, so we're good to go. Identify our ABC, we'll do that. So my A is the 1 right on front. My B is that negative 9. My C is 20. And now plug into the formula. So we're going to have x equals. And so I'm just following up here at the top, and I'm just going to fill those in. Now notice right here, that's the one thing that might catch some people. Notice how the formula says negative b right there. That means the opposite, or flip the sign of your b. So when I plug in right at the beginning of the formula here, let's even color code just for the heck of it. It'll be really pretty, right? Why don't we make the B yellow? We'll make our A red. A little easier to track with me. Okay, so we're starting with B to plug in, and notice it's a negative 9. So at the very front where it says negative B, we're actually going to put in a positive 9. Notice we switch the sign at the very beginning, okay? Then it's plus or minus the square root. And notice up here, up at the top, that square root goes across all of that material. You can't just square root the b squared and then leave out the 4ac. That minus 4ac is all inside the radical. We have to combine all of it inside before we take that square root. So it's a big square root. It's got a lot of stuff under there. So the b squared is a negative 9. And notice this as well. If that b you're plugging in is negative, he goes in parentheses when you square him. So when I square that negative 9, this is a really good side note for all of you guys. That will always become positive. Okay? If the b starts out as a positive number, when you square it, of course, it'll stay positive. But if that b you pull out of your equation is a negative number, squaring that negative, the negative is involved in the squaring. You don't square and then apply the negative. You square the negative because it's part of the number. It's inside that variable b. So if you square the negative, it's going to cancel, which means you will always, always end up with a positive value after you do the b squared. Okay? Don't forget that. All right. So there's our b's. Now we're just plugging in. We have a color, I guess green was the generic color. So minus 4. Notice that is not part of the equation. The minus 4 is just part of the structure of the whole formula. It always is a minus 4 right there. A is 1, 4 times 1 times C. C is 20. And there we go. So we've plugged in on the top row, and then on the bottom, again, that 2 is just part of the formula. Always, always, always 2. 2 times A, and the A is 1. Okay? Now from there, we do our calculations, and then we find out our two solutions. And our calculations, the bulk of the calculation, is right here. Okay? First, we'll multiply that 4 times 1 times 20, the negative 4 times 1 times 20. We'll square the negative 9. We'll combine those two, subtract them or add them, whatever you need to do on that particular problem, and you take that square root. Okay? That's most of the work of the whole equation right there. Before we get to that, let's just practice and plug in one more time. Make sure you get that piece. All come out clean. All right, this is example 1, and I'm just going to point out real quick, if you look at the original trinomial, we know it'll work out because I picked a simple factoring version. What multiplies to the 20 is a 5 and 4, and to make them add to the negative 9, negative 5 and negative 4. So we can see we can factor it, and we can also see, therefore, that we can solve it. X is going to equal 5, x is going to equal 4. We know those are your two solutions. Now, that comma does not mean I just made a point. This is not a point on the xy axis. There's no parentheses. I'm just listing that the two x values, the two solutions for x, are 5 and 4. Okay? And we'll see that in just a moment. We're going to get the exact same solution when we finish the calculation with the quadratic formula. Let's do that. Once my screen moves. Okay, so same as before. Let me get rid of this little note. All the work is really inside of that radical. So we'll start here. The negative 4 times the 1 times the 20. Well, times the 1 doesn't matter, so really you can ignore that. 1 times the negative 4 and 20 is just the negative 4 times 20, which is negative 80. Then we'll do this negative 9 squared, which is just 9 times 9 squared. The negatives will cancel, so we have 81. So here we've got square root of 81 minus 80. I'll copy everything else down just so you guys stay clear. It's that 9 plus or minus, and then 2 times 1 is just 2. So again, we'll do one more round within that. 81 minus 80 is just 1. So now we take the square root of 1. You guys know what the square root of 1 is? It's 1. Hopefully you knew that one, okay? 1 times 1 equals 1, so the square root of 1 is also just 1. So now we end up with this idea of a 9 plus or minus, let's move that 1 over, 9 plus or minus 1 all over 2. And this is where we split, and this is where we get our two solutions. So we'll just say x is 9 plus 1 divided by 2, and x is 9 minus 1 divided by 2, and we're going to get our two solutions. So we end up with 10 divided by 2, which is 5. Let me simplify it out. And then the 9 minus 1 is 8 divided by 2, which is going to equal 4. And there we go. The quadratic formula shows us our solutions are 5 and 4. Just like we saw originally, our solutions are 5 and 4. Okay, so that's how it works out. We just got to see a couple of examples. If you do end up with your square root being a perfect square, when it all finally works out and you can take your square root, then you can take that simplified answer, split it, find your two actual solutions. 3 today. There's a clean, simple 2 solutions where it actually takes the square root. Okay, so here we go. Same thing again. I think I'm going to try in just a minute, so I'm going to jump in and do this one again real quick. So the A, -3. The B, -5. And oh wait, I forgot. Did you notice what I forgot to focus on? I jumped ahead of my step 1. I've got to make sure it's set to 0 first. Solve it for 0 is just saying make sure your equation equals 0. Doesn't equal 0 yet. I have to back up. Right now, if I tried to grab a C, there is no C. But the C is the 4. It's on the other side of the equation. And when it gets moved over, it'll become -4. So I need to make sure to realize that and set that up. So my equation actually, I'm going to rewrite it real quick, would be -3x squared minus 5x. And then we need to move that 4 over. Cancel over and -4 to the other side. So the shortcut is that it just becomes -4 on the other side. Now it equals 0. Now I can pull out my ABC. So now I can see that the C is -4. I've got my ABC. Let's plug into our formula. And all I'm doing here is I'm just filling in what goes around it. Okay, so it's a -b. So since my b is -5, it needs to be +5 plus or minus the square root of b squared. And by the way, I don't know if I've said this yet. There's a lot of, you could literally go on the internet and they've made songs and like rap rhyme type things about this. They literally have made entire songs about helping you memorize the quadratic formula. So the way that you say it is that it is -b plus or minus the square root of b squared minus 4ac all over 2a. Okay? That's how you would say the quadratic formula to kind of walk it out. You know what? Maybe I'll do a, I was going to say some extra credit if you have it memorized for a quiz, but any quiz we use it on, I'll already have it supplied, so you can use it. So I guess I can't make it extra credit. All right. So b squared goes inside, and remember, the negative on the 5 is going to be squared as well. That's going to become a positive 25 in a minute. It will always become positive for that b squared. -4 times a, so -4 times that -3 times c times -4. And we got a lot of negatives in this problem. So you would just count up 1, 2, 3 negatives in that multiply. 2 of them will cancel, which means that final product is still negative because there's 1 negative left over. And the a on the bottom. And there you go. Okay, I'm hoping this is not as scary as it might have appeared when you first saw it. Okay, we set our equation to 0. We identify our ABC, and we plugged in. All there is now is to do the calculations and find your two solutions. And find one that does work out so we can see All right, why don't you guys pause it and do the calculation and carry this one out? I don't even remember off the top of my head if it works out or not. I'm going to guess no. I'm going to guess they are not whole number rational answers. Go ahead and pause it and work that one out. Go. All right, if you're not done, you should pause it. I'm going to dive in and work behind you. Okay, I'm going to start right in here. I notice there's 3 negatives, so 2 of them will cancel, but that third one stays. So in a minute, it's still going to be a negative number when I multiply. And I've got 4 times 3 is 12, times that other 4 is 48. And then that negative 5 squared, 25. And remember, it's going to stay positive. Okay, so 25 minus 48. This is another kind of special case. 2 times negative 3, negative 6. And so here we are. We're at this point. Let's do just that radical here and finish that math. 25 minus 48 is going to be 45, negative 23. So we end up with the square root of negative 23. Now, this brings up something very significant. We just ended up with a negative under the radical that we need to take a square root of. Back in the day, I don't remember the specifics, but back in the day, they were doing math, mathematicians, the very, very smart people, and they came across some equations they were trying to solve with a negative in the radical. And at that point, there was no way to do that. You can't take the square root of a negative. You'll just get an error. If you go to your calculator, put in a negative number and try and take the square root, your calculator is going to give you an error. Or it might give you an answer with an I involved. So at that point in history, they couldn't take square roots of negatives. So the mathematicians at that point decided they needed to invent or create a way to be able to deal with negatives underneath radicals so they could continue with this advanced math they were working out. And so what they came up with was this new system of numbers, and they're called imaginary numbers. And you will learn about and use these in Algebra 2, but not in my class. I bet you're happy to hear that. Okay? An imaginary number, and actually I shouldn't say S, it's there's one imaginary number, it's I. And I equals the square root of negative 1. So if we were to deal with this, we would have to bring in this imaginary number I, and it's a totally separate set of numbers within math, and we don't deal with them in freshman algebra. So the good news for you is if we hit a negative under our radical, it tells us, so for now, you get to just do this until you get to Algebra 2. Boom, boom, gone. If you see a negative underneath the radical, that immediately tells you there's no solution. You cannot take the square root of a negative, so there is no real solution. That might be how you might hear it phrased at times, because in math, we separate all the real numbers from the imaginary numbers. Those are the two number sets. So there's no real solution, or no solution is fine. And if we were to graph this quadratic, it would look something like this. Okay, we have our parabola, but notice it's too high. It never crosses the x-axis. There are no x-intercepts. So there is no real solution. There are no points that it crosses, and this is what this type of graph looks like a smiley face. When you use the quadratic formula on a quadratic equation like that will graph with no solutions, this seeing a negative under your radical, that is how you discover there are no solutions, and that is your answer. You can stop as soon as you get to that point that there's a negative under the radical. Now notice, I don't mean any negative any time under the radical. If this were a bigger number, like 125, the subtraction would work, and you'd be able to take your square root, or see if you could take the square root. But if you end up with a final value that's negative, you're done. That's a no solution. You don't have to worry about it. All right? So there's a no solution because you get a negative under your radical. Yeah, why don't you guys, I said we try, but honestly, I've done it twice. I bet you can probably do this. Why don't you walk out your 3 steps here, pause the video, and see if you can get your quadratic filled in, and then we'll go back and we'll do some calculations to finish. Go. All right, I'm going to jump in. If you're not done, which you shouldn't be yet, you need to pause it and then unpause once you've finished. All right, I'm not going to miss my first rule again. I know that I need to move this guy over to the other side of the equation, which is going to make it a negative x squared plus 3x plus 7. The minus 7, when it's canceled and moved over, would be canceled with a positive 7. So there we go. Now I'm ready for my ABC. A in this case is negative 1. The B is 3. My C is 7. And we just go ahead and plug them in. All right, negative B, so my 3 goes here, but notice it's the opposite or negative of B, so that's a negative 3 out front. And then it's just positive 3 squared inside. Minus 4AC, so minus 4 times the negative 1 times the 7 all over 2 times the A, which is just times that negative 1. All right, hopefully you got that ahead of me. Why don't we start here, and we'll walk out doing our calculations. So first thing, we're just going to work under that radical and simplify all of that down. Okay, so I'm just going to work in the radical and do that piece. So I've got the negative 4 times the negative 1 times the 7. Those two negatives will cancel when I multiply them. So I'm just going to have 4 times 7 is 28, times the 1 won't change it, so it's a 28. Then over here in front of it, we've got that 3 squared is 9. And notice the sign, the negative canceled. It's not a negative anymore. What are we going to put there? Hopefully you're saying it's a plus because the two negatives canceled, so it's a positive 28. So now under the radical, we've got 9 plus the radical, or square root of 9 plus 28. Put those together, that's 37. Anybody know the square root of 37? Nope, that's not going to be it's not a perfect square, and don't worry, I'll show you how to work with that. Okay, so now I'm just going to copy down everything else into this. So now we've simplified the whole radical, so we've got that negative 3. Plus or minus square root of 37 all over 2 times negative 1. Well, that 2 times negative 1 is just negative 2. And you can't cancel these guys out, okay? The reason for that is up top, there's 2 terms here. So to cancel off the negative that's with the 2, you would have to cancel a negative off both terms. And we're not going to try to cancel the negative with the plus minus on the 37. That's just going to make things confusing. So you're just going to need to leave it as is. And at this point, if we could take the square root of the 37, we would split this apart and we would do both pieces. But because the square root of 37 isn't it's not a whole number, it might not even be a rational number, you actually are allowed to stop here. And we can say that x is just negative 3 plus or minus square root 37 divided by negative 2. We can maybe approximate the 37 square root, or if you had a calculator, but you can stop here if you end up with something that doesn't work out exactly. We're going to go back and look at a couple of the other ones we just did, and if not, we saw here, if it's going to be something that's not a perfect square, that's going to be a really big irrational number, you can leave it, and this is an acceptable form for your answer. Or you can end up with a solution, and what that looks like, by the way, is just that your x-intercepts are just not on whole numbers. They're somewhere in the middle between values, and it's going to be this big, long, ugly decimal. Square root of 37 is about 6.1, so you'd end up with -3 plus or minus 6.159, whatever it is, divided by -2. So it's a number that exists. It's on the number line, but it's just going to be this really long, ugly decimal, but it's going to look like that. All right. All right, here's your homework practice problems. Just these two to work out. I don't remember what the top one will look like. I can kind of guarantee it won't be whole number answers. It won't work all the way out. Maybe it's no solution. Maybe it's just some not perfect squares. Number 2, I think, will work out, just 2 clean answers, so you can carry it all the way out. Okay, here's your steps. There's your equation. Just walk them out. I'll work behind you in a moment and work them out so you have the solutions. So go ahead and pause it and get to work. Go. All right, I'm going to dive in here, folks. I'm going to rewrite it so it's solved for 0. Now, to minus that over, notice is 3 minus 7, so it becomes -4. And hopefully you can see how important it is to start with it equal to 0, because the actual c is -4, not the 3, not the 7, it's the combination. So I've got my a of 4, b of -5, c of -4. Oops, I'm just going to go ahead and plug them in. Okay, b squared, so that's going to be +5. Excuse me, -b, sorry, +5. b squared is the -5 squared. Minus 4 times the a, another 4. Oh my goodness, look at all these 4s. Times the c, -4. Lots of 4s. All over 2 times a. Okay, so there we go. We've got everything plugged in. We're clearly going to have to move that guy and get some more space to work him later. All right, I'm going to work under this radical. 2 negatives, they're going to cancel. 4 times 4 times 4 is 64. And that -5 squared is 25. So we end up with 25 plus 64, which is 74, 84, 89, square root of 89, which is not a perfect square. So the final result for this one, we just need to leave it at 5 plus or minus square root of 89. We can't go any farther. It's a perfect square. All over 2 times 4 is 8. And there's our 2 solutions for that quadratic. And again, the 89, 9 times 9 is 81. So 89 is slightly more than 9, maybe 9.2 something. And so you could approximate 5 plus and minus the 9.2 something, divide that by 8, and you could get 2 approximate solutions, but I'm okay if you leave it like that. Okay, second one. That 18 needs to be moved over. It's just going to be minus 18 to move it across. Now it's 0, so I've got an a value of 1. B value of -7, and a C of -18. Let's plug it in. -b, that makes +7, plus or minus square root b squared, so the -7 is squared. Minus 4 times a times 1 times the c, -18. All over 2 times a, which is just the 1. Start in my radical. Pair of negatives will cancel, so we know it's now going to be plus. They'll be adding together under there. The 1 won't matter. It's just 4 times the 18, which is 72, I think. And then negative 7 squared, 49. And what's that going to be? 110, 121. And that is a perfect square. Did you guys know that? So we end up with 7 plus or minus square root of 121. 2 times 1 is just 2. The square root of 121 is 11. So we end up with 7 plus 11 divided by 2, and 7 minus 11 divided by 2. Okay, so just to refresh there, I split it because of the plus minus. It was 7 plus 11 and 7 minus 11. And those are our two solutions for x. You just work those out. So 7 plus 11, 18 divided by 2. And 7 minus 11, negative 4 divided by 2. There you go. All right, so hope you guys got that. See you tomorrow in class.